2024 YR4 is on its way. Right now, a rock bigger than a football field is hurtling through space. NASA gives it a 1% chance of hitting Earth, and that's way higher than it sounds. This is 2024 YR4, and it's forcing us to answer a simple question. Are we finally ready to defend Earth? When Atlas astronomers in Chile first spotted YR4, they probably didn't sleep that night. The data showed something unprecedented, a 1% chance of impact. Now, you might think 1% sounds small, but in space terms, that's like a bullet grazing your ear. NASA immediately rated it as a level 3 threat on the Torino scale, the highest rating any asteroid has received in decades. But what are we actually dealing with? Initial measurements put this cosmic bullet somewhere between 40 and 90 meters across. Picture this. If YR4 landed in the middle of Central Park, it would stretch from one side to the other. And that's just the small estimate. If 2024 YR4 is on the very small side, say around 20 to 40 meters, it would likely explode in the atmosphere before hitting the ground. Think of the 2013 Chelyabinsk meteor, which was about 20 meters wide. It exploded 14 miles up, releasing energy roughly equivalent to 440 kilotons of TNT. The shockwave shattered windows over a 200-square-mile area and injured over 1,600 people. A slightly larger asteroid at around 30 to 40 meters could produce an airburst delivering 1 to 5 megatons. That's enough to blast out windows, shake buildings, and cause injuries over tens of kilometers. But it probably wouldn't dig a crater or wipe out an entire city. Step up to a medium scenario, around 50 to 60 meters across. In this case, the asteroid would pack energy similar to the infamous Tunguska event of 1908, where a 55-meter object exploded with about 8 to 10 megatons of energy. Imagine the force of a nuclear bomb flattening an entire city within seconds. While Tunguska struck a remote part of Siberia and left few human casualties, a direct hit on a metropolitan area today could be catastrophic, potentially obliterating everything in a 10 to 20 kilometer radius. And then there's the large scenario. If 2024 YR4 turns out to be closer to 80 to 100 meters, it could punch through the atmosphere and hit the ground nearly intact. The energy released might be tens of megatons, comparable to dozens of nuclear weapons exploding at once. This would create a crater several kilometers wide, obliterating everything near ground zero and sending shockwaves and fires well beyond the impact site. It might not trigger a global extinction event like the Chicxulub impact that wiped out the dinosaurs, but it would be among the worst disasters in human history if it hit a populated area. But how exactly does an asteroid deliver its destructive force? It all depends on whether it explodes in the air, a so-called airburst, or makes a ground impact. In an airburst, the asteroid disintegrates at high altitude due to intense atmospheric pressure. The explosion sends out a powerful shock wave and thermal pulse that can break windows and injure people, much like what happened in Chelyabinsk. On the other hand, if the asteroid survives its fiery plunge and smashes into the ground, it creates a crater and sends out a supersonic shock wave that pulverizes everything nearby. The difference is critical. An airburst spreads the energy over a broader area with somewhat less concentrated damage, while a ground hit concentrates the devastation into a smaller, almost apocalyptic zone. History gives us some clues. In 2013, the Chelyabinsk meteor showed that even a relatively small rock can cause serious disruption, even if it doesn't hit the ground. Then there's the Tunguska event, where an explosion over Siberia flattened 80 million trees over an area of more than 2,000 square kilometers. And if you look even further back, the Barringer crater in Arizona, formed by a roughly 50-meter asteroid, shows that a ground impact leaves a lasting scar on Earth. The Chicxulub impact, which was many times larger than YR4, reminds us that size matters when it comes to global effects. But for YR4, even in the worst-case scenario, global catastrophe isn't on the table. Location is everything. If 2024 YR4 were to hit a densely populated area, a major city, for instance, the consequences would be dire. A direct hit could potentially cause millions of casualties and trillions of dollars in damage. The shockwave, thermal pulse, and ensuing fires would decimate infrastructure and lives alike. In contrast, if the asteroid strikes remote land, such as a desert or forest, immediate human casualties might be minimal, though the environmental damage would be spectacular. And given that about 70% of Earth's surface is covered by ocean, there's a high chance the asteroid will hit water. An impact in the deep ocean might just cause a big splash, but if it occurs in shallow coastal waters, it could trigger a tsunami that endangers coastal cities. Speaking of tsunamis, an ocean impact near populated coastlines could send out waves several meters high, flooding low-lying areas and causing further destruction. Even a seemingly modest tsunami can be deadly if it strikes without warning, especially in coastal regions where millions of people live and work. So what does this mean for us humans? In the worst-case scenario, a city hit by a 50 to 60 meter asteroid, the immediate death toll could be in the millions. The economic damage would be astronomical, potentially costing trillions of dollars, not to mention the long-term psychological and infrastructural impact. On the flip side, if the asteroid were to hit remote land or the deep ocean, the immediate human cost might be close to zero, though there could still be indirect economic or environmental consequences. Now, here's where things get interesting. With the current observations, scientists can't pinpoint exactly where 2024 YR4 might hit, if it does hit at all. The possible impact zone stretches along a long corridor that could cross oceans, continents, or even multiple countries. But as more data comes in over the next few years, that uncertainty will shrink. By the time the asteroid makes another close approach in 2028, and then again in 2032, astronomers expect to know its path with much higher precision. If an impact looks increasingly likely, there would be weeks or even months of warning, giving authorities a chance to evacuate threatened areas. Evacuation on such a massive scale is no small feat. Modern evacuation protocols, like those used for hurricanes, can move millions of people in days. However, evacuating a long, uncertain corridor, if the impact zone isn't pinpointed until just days before, presents significant challenges. That's why early detection and precise tracking are so crucial. With enough warning, cities could be evacuated and emergency measures put in place to minimize loss of life. Of course, beyond evacuation, there's also the hope that we might prevent the impact altogether. In recent years, significant strides have been made in planetary defense. The most promising technique so far is the kinetic impactor, ramming a spacecraft into an asteroid to change its trajectory ever so slightly. NASA's DART mission, which successfully nudged the moonlet of an asteroid in 2022, proved that we can indeed alter an asteroid's course. For 2024 YR4, if further observations confirm a threat, a deflection mission could theoretically be launched by the late 2020s, years ahead of the potential 2032 impact. There are also more extreme options, like using a nuclear device. Rather than blowing the asteroid to bits, a nuclear explosion near its surface could vaporize a thin layer, generating a thrust that nudges it off course. Nuclear options come with their own set of challenges, politically and technically, but they remain on the table as a last resort. Other futuristic ideas, like the gravity tractor, using a spacecraft's gravitational pull to tug the asteroid off course, or laser ablation, using concentrated beams to vaporize surface material, are intriguing but probably not practical for a threat on this timescale. Even if we get to the point where a deflection mission is needed, success isn't guaranteed. Coordinating an international response, building and launching a spacecraft, and executing the mission with pinpoint precision, all within a matter of years, are enormous challenges. But the same urgency that drives evacuation plans also fuels our planetary defense efforts. The world's space agencies are already in constant communication, and preparations are underway to ensure that if 2024 YR4 remains a threat, we're ready to act. It might be comforting to know that statistically, the odds of any one of us being affected by this asteroid are minuscule. With current estimates, the chance that 2024 YR4 actually hits a populated area is around 0.17%, and your personal risk is even lower, comparable to being struck by lightning or getting into a car crash. In fact, you're thousands of times more likely to die in a car accident or from falling down stairs than from this asteroid. So while it's important to study and prepare for such events, the day-to-day risk is extremely low. Now, if you're sitting there thinking, this is all really interesting, but what can I do if the worst happens? The answer is simple. Follow official instructions. If evacuation orders are issued, leave immediately and calmly. If you must shelter in place, find the sturdiest, most protected location you can, ideally underground or in an interior room, away from windows. Basic survival techniques for blast events apply here. Drop in cover, stay away from windows, and have an emergency kit ready. These steps, common to nuclear or tornado emergencies, could save your life in the unlikely event of an asteroid airburst or impact. But here's the mind-blowing part. For the first time in Earth's 4.5 billion-year history, a species has the technology to prevent its own extinction. That species is us. We're not just observers anymore. We're the defenders of Earth. 2024 YR4 isn't just a threat, it's our chance to prove it.